Hello, am I audible? Okay, only three people have joined. Okay, so you guys might have finished assignments 1 and 2, right? Which one? Question number 9. Okay, so it says, yeah, you're saying something? Actually, if you compute determinant of this matrix, okay, so determinant will be, let's compute it. Uh, Determinant will be 24. Yeah, that is correct. Invertible, actually the determinant property is also used to compute your check, because ultimately when you invert the matrix you determine the determinant and you basically divide the operation, that whole operation, by the determinant. You multiply it by 1 by determinant, correct? So yeah, that is why if the determinant is 0, ultimately you won't be getting anything, it will be infinite. So yeah, that is correct. So option A and D both are correct. I know, but I don't know what course instructor. You can ask it on that forum. Put this question on that forum, okay? Both of answers are correct. They should be correct, okay? And you have the mark. So this question will be flagged as it won't be counted towards your grade in the end. I think that is a procedure which NPTEL follows. I don't know about in detail. Okay. Any other doubts? Assignment 2. Okay. Sorry? Correct. It's a very simple question. Just people are joining. Can you wait for 2 minutes? Let other people also join. Okay. Then we can discuss it together. Okay. I think I started earlier, quite early today. Actually, I was not looking at campus. I had to come to Ghaziabad. So I just thought of winding it soon. So that, anyways, for first half an hour, hello. For first half an hour, let's discuss all the assignment doubts. And for the remaining part, I would, if you want, actually, I have previous year's assignments available with me. Okay. Okay. So I can discuss those assignments for your better understanding. So like week 3 deadline is still not over. I cannot discuss it, but I have previous year's assignments. Okay. So after I finish all the doubts for week 1 and week 2, I will be discussing that. Ultimately, I think professors will provide the answer keys and solution to these assignments later in the course. Okay. So those doubts might be solved here as well. Let's wait for 5 minutes. by that time. Anybody else has any doubts? Whatever doubts you might have, doesn't matter if it's silly, advanced. Sorry? The people who have registered for previous year, they will be getting it. I cannot share it like that. I don't have permission to share it like that. I can only discuss it here. Okay. So what I can do is I can show it on screen. I can write solutions on my iPad and then I can post two solutions on Google Drive link. That's the best I can do, but I cannot directly share it. So let's wait for 5-4 minutes. Let's see how many people join. Today the strength is very low. I expected at least 20 people to join. I don't think so people will be joining. Anyways, just give me 2 minutes. Let me connect my iPad. Okay, some other has joined. Okay, so is my iPad visible? Okay, so 613 people have not joined. Let's start. So you had a doubt in question number 3 and 4. Okay, so let me draw the matrix here. So let me tell you the general convention. Okay, the convention is that the problem which you might have faced is, just let me pin my camera. I have to basically upload this recording. Okay, yeah, fine. So the convention is that whatever is given on x-axis is independent, while whatever is given on y-axis is dependent. Okay, so it is a general convention which is followed, but let me draw one more. But in probability or whatever we write, okay, so let me write it like this: mine present, mine absent, mine detected, mine not detected. This is 0.8 y, this is x 0.6. Occasionally it may detect some random objects, fail to detect an actual mine, conditional detection probabilities, where rows detect columns detect row state. Okay, so see what rows are detecting. These rows are saying it's present or not, while these columns denote row state. So what is the probability which will write? Probability that mine is detected such that mine is present, okay, is 0.8. So probability that mine is detected such that mine is not detected such that mine is present will be 0.2, right? Am I right, Sojanya? Okay. Similarly, for probability that mine is detected but mine is not present, absent is something x. The probability mine is not detected and not present will be 0.6, so this will be 0.4. Correct? If I think you might have confused like this. You might have made these two variables dependent. Oh, sorry. Okay. The cost matrix quantifies the cost or loss associated with misclassification instances. Consider the following loss matrix. Determine the cost of reporting mine not detected. Okay. So what is the formula for this? Was some formula taught in the course? Hello? Am I audible? Hello? What is the formula for this? Just a second. Sorry? Just a second. I'm facing some issue with audio. Yes, Praveen. Just a second. Okay. Yeah. Yes, hello? Am I audible? Yeah, what were you saying? So what you are saying is 0.8 into 0 plus 0. Uh, what is there? 0.4 into 5, that gives me a for 2. Correct? This is what you are saying. Hello? Okay. But I think it should be column sum property, no? It should be, no. Yeah, it should be column sum property. 0.2. 0.8 plus y equal to 1, y equals to 0.2. No. This is, you have to detect the cost for this, na? Hello? So how are you going to detect the cost? What you are saying is this column sum property will not hold true in this case. Okay? Anybody has any idea? Any ideas, anyone? Yes. False, false positives, not false positives. They will be actually not false positives. You have to find sort of true negative sort of thing. So say you find a, you say mine is not detected, okay? But it's present there, okay? And it blasts. So mine is not detected, but it's present. So this will be 0. What was there? 0.4 was there, right? So 0.4 into 20 is 8, right? Hello, am I audible? Arey, hello, am I audible? Hello, am I audible? What was I was saying? Sorry, my internet is a little wonky today. Actually, it happens a lot in IIT. Just a second. So what I was saying is, let me connect my iPad again. What I was saying is, what is misclassification error generally? Say someone has cancer, okay, and I identify that person does not have cancer, and that person gets screened, and the person goes home, stops worrying about his life. Yeah, I'm presenting it. I'm not writing anything actually. I'm just saying. So what I was saying is, assume a person has cancer and the doctor misclassifies it and says, yeah, you don't have cancer. Okay. So in that case, what happens is, the person goes home, enjoys his life, and one day he dies. So that is the cost of misclassification. Okay. Correct. Okay. So assume you have been given this thing. You have been given. Sorry, my screen. I cannot present. Praveen, just a second. Just a second. Yeah, Praveen. Speak. Yes. Sorry? No. The assignments cannot be reevaluated. Once they have been submitted, you cannot change it. So I'm sorry about that, but that's the NPTEL policy. I cannot. Actually, I'm also not the course TA for this course. I'm just PMRF TA, so I don't have contacts with professors. So, anyways, I cannot do anything. Sorry? If you think, yeah, please. Yes, yes, the solutions might be provided by professors because last years they were provided. Okay, so they might be provided. So just wait for a week or two. They will be giving it. Or you can raise a query. You can raise a query in the announcement section. You can raise a query here in Q&A on NPTEL SWAYAM portal, and the professors might provide it. Okay. Yes. Great. Yeah. So yeah, what I was saying is, so this is the cost of misclassification. Okay. So here, why is the misclassification which we are talking about? So if a mine is present, sorry, if a mine is present and mine is not detected, in that case, y is that probability is y, which is 0.4 multiplied by 20. What you get is 8. Correct? Anyways, this probability doesn't matter because it will be 0. If a mine is present, it's detected. If a mine is not present, it's not detected, it will be 0. But these two costs are important. If a mine is not present, it's detected. In that case, you have to dig it and you have to check, and ultimately you will not find the mine. So this cost will generally be low. Okay, this will be low compared to this. If a mine is present, it's not detected, gets blasted, and everything gets destroyed. Okay, got it? Cool. Yeah, I don't use that terminology. I don't use that terminology because people generally get confused in that type 1 or a type 2 error. So I explain it with this example, cancer one. Uh, so generally, what we call is it's uh, false. It's not called false positive. It's actually called false negative. Okay, false positives are say so no, it will be not false positive. Just a second. If you're positive, yeah, it will be false positive. No, 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 no. This is why I get confused. That's why I don't use this terminology. That's why I explain it like this. Sorry. Yeah, so that's why the name is confusion matrix. I get confused. Anyways, any other doubts in week 1, week 2 assignments? Question 5, yes. Correct. Correct. Okay, so how did you solve this question? Yeah, so no, 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 just do. Okay, do one thing. So, okay. Hello? Yes, please speak. Hello, Praveen? What was speaking? You were saying something. Uh huh. Mm-hmm. Mm-hmm. Who asked the question? That person, can he speak? Yeah, please, please. Okay. 0.1 and 0.4. So 0.1, where does 0.1 lie? Okay. Uh, I didn't get the question. What you're saying? Okay. Yes, yes. That's what I'm saying. That's what I'm saying. How did you determine it? Okay. Which is correct, 0.25 and 0 minus 0.75. So where does 0.25 lie on X? Yes. Acha, tell me one thing, what is the maximum height a PDF function can reach? What is the maximum height a PDF function can reach? Yes, yes. Mm-hmm. Correct. Yes. No, how what I'm saying is, okay, this is a probability density function. Okay, means the probability of picking a zero from here. Okay, from both both these things. Correct, is one. Should be one. At max, the probability can't be one, right? So why is it if I pick a sample from y which is 0, if I pick y is equal to 0, the PDF function will give me 2. Why is it so? Getting my point? Okay, let me explain. So what is a probability density function? Probability density function gives you something in this range, 0 to 1, something like this, correct? What happens if this PDF reaches 2? Tell me, I'm asking you. I'm getting some noise. Hello? Yes, yes. Okay. Hello. At origin it will reach 2, but probability should be, say, what should I say? Hello? The probability should be in the range, right? 0. Okay. I know what you are saying. I'm saying if I find the probability of this, say probability of -1. Probability of -1 in X is 0, right? Probability of finding -1 is 0. Yes, that's what I'm saying. So why is this y function given up to 2? That's what I'm asking. Any idea? So now answer my question first, then I'll explain. Yeah. Okay. So once you say probability of finding -0.5, also probability of finding 0 is 2. Okay. Probability of finding 0 is 2. Let me write it. So probability of finding, 0. I'm not talking about y plot. I'm talking about y plot is 2. Correct? Which is wrong. It should be at max 1. Right? So what you do is you scale it down. Because it's okay. Correct? So once you scale it down, the x-axis, yeah, getting now you're getting it. Yes. Okay, so let me explain it one by one. This is -1. This is 1. This is 1. This is 2. This is -0.5. Did anyone try to Google this question and check? What did you find? How? You shifted the axis, right? Yes, correct. What will be the range of x-axis? Correct. -0.25 to 25. Correct, right? Okay. But in that case also that's -0.25 will be present. Yeah. So option C. This range is -1 to 1. Okay. Whatever options are there, they are falling within this range, right? So all x's are correct. Right? All x's are correct. Let's talk about y. So this PDF reaches to the height 2, which should not happen. A probability density function should reach to a height 1. Correct? At max 1, it can reach to 0.8 also, but at max 1. Just a second. So what you do is you scale it down. So once you scale it down, this graph comes somewhere here. How did you scale it down? You brought this whole, the slope should remain same. You cannot change the slope. Otherwise the function gets disoriented. Correct? So in that case you divide the whole slope by the slope should change actually. The axis should shift. Something like that. So these things will be parallel to each other. And ultimately what you will be getting here is 0.25 to 0.25. Now the range is -0.25 to 0.25. Which one is not satisfying? Third option, right? -0.75 does not lie in this. So third option is correct one. Got it? Yes. If you are saying D option, so D option is -0.25, which falls in this probability distribution. Although the probability is 0, but it falls inside this probability distribution. But I cannot say anything about -0.75. It's out of this domain. Okay. Any other question? Yes. To confuse you. Simple. Otherwise the answer would be just visible in front of you had they given it in that range. Otherwise it was very simple. All options were correct actually. Yeah, so that's why they give it that way. Any other question? Anyone any doubt in all week 1 and week 2 assignments? Fourth one. Fifth. I just told na. Eight answer is 8. You were there, right? You only asked the question, right? Ha. Okay. So yeah, any other doubts? Any question you might have doubt in week 1 and week 2? Don't ask question 9 and 10, they are very simple. Like literally you have to just use the formula of expectation and variance. I'm just saying, kidding. Like, if you have any doubts, you can ask it. Okay. So any doubts till now? Okay. And actually, yeah. So if you see here, so what I gave two examples of misclassification. There are two misclassifications. I don't know what is type 1 and type 2. I forgot it. I'm not telling it. Okay. I'm telling it in this way. So just think. Sorry. Just consider there's a person who has cancer and that person went to doctor and that person was misdiagnosed as non-cancerous. Okay. So in that case, that loss of resources will be high. Okay, that person might die, that family will suffer. Okay, but now consider that there's a person who doesn't have cancer that gets diagnosed with cancer, and so it has to go through 3-4 more channels to get verified if it has cancer or not. So some money might get spent, but ultimately that person will live. So in that case, the loss will be low. But if they are correct diagnostics, like in this case, 0.8 and 0.6, in this case, you don't have to worry about loss. If the person has cancer, gets diagnosed, good. It doesn't have cancer, doesn't get diagnosed, good. So if they consider there's a mine which is not present but gets detected, in that case I would have to basically dig the whole round and check if the mine is present or not. So in that case the loss will be low. So here in this case the loss is 5. Now consider there's a mine but it does not get detected and it gets blasted and kills 3-4 people around it. So the loss will be high, the loss is 20. So what you have to find is you have to find misclassification loss. So misclassification loss is generally the probability of finding the probability of that particular instance into the total loss, which is 0.4. It was 0.4. It will be 8. This is how we come to this answer. Got it? No, I just discussed it. It should not be 0.2 here because this is an independent variable. These variables are dependent on this. So this becomes like this. So mine P, what I'm saying. Minus, sorry, my bad. Ultimately what x will be 0.2, y will be 0.4. Okay. So how it's calculated? Oh, just a second. Okay. So it will be misclassification sums will be, that will be 0.2 into 20 plus 0.4 into 5, right? Something like that. That is 2, this is 4. Oh, sorry, I got confused. So if a mine is detected, y becomes 0.2, x becomes 0.4. Sorry, I put it here like that only. Oh. Mine not detected. Determine the cost of mine not detected. Yeah, so mine not detected will be 0. This thing. Yeah, that should be 4 only. It should not be 8. Correct. So you can also report this answer as incorrect in discussion panel. You can report it incorrect, and professors will mark it as incorrect, and that question might be thrown away from this calculation of marks. Okay, sorry about that. Okay. Any other doubts? Okay, so let's leave this and let's go to last year's question papers. Last year assignment 1. Okay. I might have to open a new tab here and just a second, let me log in. Okay, so let me present my screen. Is it visible? Okay. So these are the last year's questions and solutions. So I will open it in new tabs. Very similar questions yet very simple. Are you able to see question number 1? Okay, so read this question, solve it. If you're not able to solve it, then let me know. Anyone of you can unmute yourself and just read it aloud. Can you read it out loud? Okay. Hmm. Hmm. Okay. So let me explain the answer directly. Okay. So these are the solutions. So to convert an 8-channel audio stream into 2-channel, so we do not need to change this 1024, we just need to change 8 to 2. So we need to multiply it by some matrix which is of size 8 into 2 or 2 into 8, correct? Am I right? Okay. So ultimately you have to multiply 10242 into 8 to get this. So what you have to do is, you have to multiply 1024 into 8 into 2 to get 1024 into 2. So this is the size of the transformation matrix, and the final matrix will be of this size, correct? Okay, so yeah. So this is the about this matrix multiplication. This portion is interesting. Read it out aloud. Someone from the audience. Yeah, read it. after this magnification. Hmm. Hmm. These four options. Can anyone tell me which one is correct? Almost there. Ah, no, no. Second option is correct. Okay. So if you guys know, can anyone tell me what? Okay, just leave it. I will tell it. So determinant of this matrix can be found using matrix determinant lemma. This lemma is something like this. Okay. Any invertible square matrix and column vectors is given by this. So if you transform this, so you ultimately what you get is you get determinant of A plus 1 plus dot 1 plus B transpose. So you basically swap these matrices. This is the lemma. So if you put it here, determinant of I is always 1. So this equation simplifies to B transpose A. Correct? And once you write in this format, you get this commutative property. You cannot get it as a TA, only I have the access. Okay. So either the answer will be B transpose A or A transpose B. It will not be AB transpose or AB transpose or BA transpose, out of that. Okay. This transpose sign gets shifted here. Now this one, this is a very nice question. The eigenvectors of eigenvalues of this thing. My screen stopped sharing. Now is it visible? This one. What will be the answer? What? A, B, C, D, what? No, no, no. Option number B is incorrect. If you are just inverting it, then it's not correct. These are eigenvalues. Where is it written determinant will be 0? Actually, it's not that way, because if you convert, say you have a matrix A and you invert it, so you will not be getting inverted values. Okay. So this is the problem with inverse matrix. Inverse matrix is not what it seems like, what it sounds like. Okay. So the answer will not be inverse of this. No, it's not correct. Okay. Any idea? Somebody wrote something. We can. Let's see the answer. Okay. Actually, I cannot share my screen and connect my iPad, both things together. So I'm just reading out loud from here. Can you see what I have underlined, what I have highlighted here? Hello? What is this sound coming from behind? Okay, discussion forum link is present in Swayam portal. You open that, the videos where the videos are present, just the Q&A is written, the Q&A. It's present there, let me show you. This thing, array, I need to demagnify it. This Q&A part. Discussion portal is present here. Since A has a 0 eigenvalue, when eigenvalue is 0, it means the matrix is not inverted. Now is it visible? Can you read it? Out loud. Okay. Hmm. Hmm. Okay. So let me explain the answer directly. Okay. So these are the solutions. So to convert an 8-channel audio stream into 2-channel, so we do not need to change this 1024, we just need to change 8 to 2. So we need to multiply it by some matrix which is of size 8 into 2 or 2 into 8, correct? Am I right? Okay. So ultimately you have to multiply 10242 into 8 to get this. So what you have to do is, you have to multiply 1024 into 8 into 8 into 2 to get 1024 into 2. So this is the size of the transformation matrix, and the final matrix will be of this size, correct? Okay, so yeah. So this is the about this matrix multiplication. This portion is interesting. Read it out aloud. Someone from the audience. Yeah, read it. After this magnification, these 4 options. Can anyone tell me which one is correct? Almost there. Ah, no, no. Second option is correct. Okay. So if you guys know, can anyone tell me what? Okay, just leave it. I will tell it. So determinant of this matrix can be found using determinant matrix determinant lemma. This lemma is something like this. Okay. Any invertible square matrix and column vectors is given by this. So if you transform this, so you ultimately what you get is you get determinant of A plus 1 plus dot 1 plus B transpose. So you basically swap these matrices. This is the lemma. So if you put it here, determinant of I is always 1, so this equation simplifies to B transpose A, correct? And once you write in this format, you get this commutative property. You cannot get it as a TA on the I have the access. Okay. So either the answer will be B transpose A or A transpose B. It will not be AB transpose or AB transpose or BA transpose, out of that. Okay. This transpose sign gets shifted here. Now this one. This is a very nice question. The eigenvectors of eigenvalues of this thing. My screen stopped sharing. Now is it visible? This one. What will be the answer? What ABCD what? No. Option number B is incorrect. If you are just inverting it, then it's not correct. These are eigenvalues. Where is it written determinant will be 0? Actually, it's not that way, because if you convert, say you have a matrix A and you invert it, so you will not be getting inverted values. Okay. So this is the problem with inverse matrix. Inverse matrix is not what it seems like, what it sounds like. Okay. So the answer will not be inverse of this. No, it's not correct. Okay. Any idea? Somebody wrote something. We can. Let's see the answer. Okay. Actually, I cannot share my screen and connect my iPad, both things together. So I'm just reading out loud from here. Can you see what I have underlined, what I have highlighted here? is sound coming from behind. Okay, discussion forum link is present in Swayam portal. You open that, the videos where the videos are present, just the Q&A is written, the Q&A. It's present there. Let me show you. This thing. Array, I need to demagnify it. This Q&A part. Discussion portal is present here. Since A has a 0 eigenvalue, when eigenvalue is 0, it means the matrix is not invertible. So if the matrix is not invertible, A inverse does not exist. None of the options are correct. Got it? Okay. This is easy. I'm skipping it. It's just solving. Okay. So anyways, you can just find a determinant and you can just tell it if the solution exists or not. If the solution doesn't exist, there will be no solution. Otherwise, there will be some solution. Okay. So I'm just leaving it. Let's solve question number 5. Can anyone read it out loud again? Correct. So as we can see, A transpose A is I. This means invertible, A is invertible, something like that. Am I right? Anybody say something? Yes. It can be less than 0 as determinant can be less than 0, yes. It should not be equal to 0. That is the condition. What is determinant? Determinant is basically area. Yes. Okay. Well, let me tell you determinant very easily. That's if you might have studied 3 blue, 1 brown, that course. So determinant is basically area, and area is a vector. Okay. So vector can be positive and negative in the direction. If you take the negative direction, it becomes negative. So this is what determinant is. Determinant can be negative as well. Zero eigenvalue looks like a linear vector space. Zero eigenvalue looks like that vector basically does not exist. Okay, so if I give you say 3 orthogonal vectors, and if I give you some value in xy plane, say, okay, and if I ask you what is the eigenvalue for z axis, that will be 0. So in that plane the vector does not exist. So if you take 3 matrix, basically invert it, so in that space you cannot invert it because it does not exist there. Correct, Ganesh? Okay. Let's see the solution. Question. When A transpose A is there and Y is equal to X is given, say something like that, L2 norm is preserved, meaning this is because once you do this thing, okay? Well, obviously Y square is this multiplication of this with this. This becomes X transpose A transpose A transpose A is I, X transpose X is X square. Got it? I think somebody missed. Yes, orthogonal transformations are just rotations. So, okay, you are answering the question. I will read this one. Consider two matrices A and B, where A is 3, 4, 3 into 4 matrix, B is 4 into 3. We perform the following operations sequentially. A and B resulting in C. Okay, take transpose of C, perform element-wise Hadamard product of C with an identity matrix, add 3, 3 cross 3 matrix T, whose all elements have value 2. Okay. Lot of options. Somebody just read them out, answer the question. Anyone? Okay, sorry. Yeah, read it. Read the options. So the options B and D means second and fourth might be the correct one. Okay, because ultimately we are multiplying it with the identity matrix. But anyways, let's see the answer. Product of 3 cross 3 matrix C, since number of rows and number of columns determine the dimensions. Okay, so this becomes a 3 cross 3 matrix. Transposing C does not change the dimensions but swaps its rows and columns. Okay, the Hadamard product of C with an identity matrix zeroes out all off diagonal elements, leaving with only diagonal elements unchanged. Okay, adding a 3 cross 3 matrix D, where each element is 2, resulting in a matrix from previous step increases each element by 2. So off diagonal elements which were zeroed out become 2 and diagonal elements are increased by 2. Correct? So the correct option is 3 cross 3 matrix whose diagonal elements equal to the sum of corresponding elements of rows B and D plus 2 and off diagonal elements are 2. Okay. Equal to the sum of corresponding row in matrix A and off diagonal elements are equal to 2. Sorry. Option B is correct. Plus, it's incomplete, right? Corresponding elements from rows of A and columns of B plus 2. Sum of corresponding row. This option is incomplete, right? I think that might have been the problem last year. Any ideas? Hello? So ultimately the options become this off diagonal elements plus 2, okay, as it is written 3, equal to the sum of corresponding elements from rows of A and columns of B plus 2 and off diagonal elements equal to 2. The option written here are diagonal elements sum of corresponding row in matrix A. with what? Corresponding column in matrix B. Anyways, you got the explanation right. Just leave the options, okay? We don't have time to discuss all these vagueness. This question is very simple. Okay, consider three vectors. Are these vectors linearly independent? 1 0 1 0 1 1 minus 1 1 0. Are they linearly independent? Someone is saying something? How? Yes. 1 minus 1 0 0. So summing this, summing rows 1 and 3, you will get row 2. So linear combination can be is possible. That's why they are not linearly independent. So as you can see, 1 minus 1 0, 0 plus 1 1, 1 plus 0 1. Okay, so that's why they are not linearly independent. And ultimately you can also find a determinant and check. So determinant 0, this means not independent. Can someone read this question out loud? Okay, I will read it. In an experiment, data is represented by a matrix M which records interaction intensities between 4 particles. So you get 16 elements at most. Matrix is given as this. The trace of matrix M is used to calculate the total intensity of self-interaction among particles. You are also given transpose of matrix M transpose. What is the relationship between total intensities calculated using M and M transpose? It should be same. Yes, that's correct. Why should it be same? So basically, what you do is once you when you want to compute the intensities, what you do is you multiply this whole matrix by itself. Self-interaction to compute the self-interactions. Okay, some sort of Hadamard product type of thing. So trace is basically that is sum of diagonal elements. Okay. So ultimately, what you have to do is you have to calculate the since diagonal elements are identical, they are identical. 3 2 1 6. Okay, once you swap it, since diagonal elements of M and M transpose are identical, this implies the total intensities is okay. So if you are computing self interactions, in that case you are computing trace. Trace is the sum of product of diagonals. Okay. But if you wanted to compute off diagonal relationships, so if you have studied this Hilbert space, I'm writing it here. Hilbert space. Ganesh, you can unmute yourself and say, I don't hear the ding of your message, so I come late here, okay? So if you study Hilbert space, what you will find is Hilbert space and this quantum interactions, they are basically modeled in Hilbert space and they utilize the trace of matrix. So in word embeddings, and once if you want to compute word embeddings in quantum space, you want to model self interactions and off diagonal interactions. In that case, the same thing is happening, and that's when you can tell that self interaction between what we call transposes are basically the same. Okay. Consider the following matrix is C invertible. Is C invertible? Can anyone tell me? It's very simple. You can compute the determinant, or you can check if one row depends on the other or not. Okay. So which row depends on the other row? Can anyone tell me? Like how are they not linearly independent or whatever it is? Sorry. Yeah, this is the 1 into 2, 2 into 4. Yeah, correct. This is basically twice of the first row, third row. Okay. Coming to the last question. Consider this vector V. Which of the following norms will be the norm of vector? Which of the following norms will be the norm of vector? Will the norm? Okay. Which of the following norms will the norm of vector V be minimum? What is L1 norm? L1 norm is summation. Summation is -5 plus 5 0. L2 norm will be at the maximum one. Okay. L3 norm will basically cube it. So this will become -9 -4, that will -13, 16 and 117. This will be positive. So I think L2 norm will be minimum. Okay, and why is L infinity norm minimum? What is L infinity norm? Okay, got it. L infinity norm is maximum of these things. So yeah, L infinity norm will be minimum. So yeah, this was week 1 assignment of last year. You want me to discuss week 2? You want me to discuss week 2 assignment as well? Time permits. We have 45 minutes. So we can always discuss these things. Okay. Actually, not a lot of people joined today, so I was planning on teaching Python, etc., but people haven't joined, so I cannot do anything. Let's discuss assignment for now, and let's see. Solution. Let me open the solution as well. A survey is conducted on a group of 1,000 people. 600 are female, 400 are male, 200 females and 100 males have college degree. Let X be a random variable representing gender, 1 for female, 0 for male. Y be a random variable representing education, 1 for degree, 0 for no degree. Find the conditional probability such that X is 1. Means education, you have a degree, and you have a, given that you are a female. Given that you are a female, you have a degree. Okay? Let's directly go to the solution. So we have 300 males. Sorry, 300. How many males are there? 400 are male, 200 females, and 100 male have college degrees. So this means 300 males do not have college degree out of 1,000 people. So 0.3. Male with a degree are 100. And female without a degree are 400, and female with a degree are 100. Sorry, 200. So conditional probability is y given x is written y comma x, x comma y divided by y. So this is 0.2 divided by 0.3, which gives you 0.3 basically is probability that there are females. So females are how many females are there? 600 out of 1,000, so that is basically 0. Sorry, just a second. Okay, females with a degree. So there are 200. No, y is, what is y? Y is, okay, how many people have degree? 600 people. Sorry, 300 people have degree. So this means 0.3. Okay, so 300 people have degree, out of which this 0.2, this means females with a degree are 0.2, so this gives you 0.67. Coming to the next question. An insurance company classifies insured policyholders into accident prone and non-accident prone. Their current risk model works with the following probabilities. The probability that an accident prone insured has an accident within a year is 0.4, while the probability that a non-accident prone insured has an accident within the year is 0.2. If 30% population is accident prone, what is the probability that a policyholder will have an accident within a year? Within a year, okay, very simple solutions. Probability that someone will have an accident within a year, and A1 is that, and A person is accident prone. So to find probability of A1, you have to find all the probabilities. So that will be probability of A1 given A, probability of A, probability of A1 given not A, probability of not A. Okay. So 0.4 into 0.3 and plus 0.2 into 1 minus 0.3, that is 0.26. Okay, so basically this is summation, conditional probability, sum of conditional probabilities formula. Okay. Now we have to find someone, what was the question? Probability that policyholder will have an accident within a year. Okay. Sorry, this one. What is the probability that, suppose the policyholder had an accident within a year, what is the probability that he or she is accident prone? So, probability of A given A1 you have to find. So, that is basically A1 given A into PA divided by P of A1. Okay. So, if you multiply this thing here, you will get same thing. Okay. So, you solve it, you get 0.46. Simple question, simple solution. Just a second. Okay, any other doubts in this question? I don't think any doubts will be there. I'm not discussing probability questions. Let's see some other question. What is the probability? Okay, I think the week 2 was probability only. Let's discuss this one. It was asked in our assignment as well. And our week 2 assignment, given a random variable, what with the following probability distribution? X1 is with probability 0.2, X2 is 3 and X3 is 0.5. What is the expectation? How will you find the expectation? Anyone? Hello, am I audible? How will you find the expectation? Summation of probability will always be 1. So you mean the expectation is 1. Yeah. So this x is equal to 1. It does 1 into 0.2, 2 into 0.3, 3 into 0.5, 2.3 is the probability. Variance is somewhat given by this formula. The probability of expectation of x square minus expectation of x whole square. So x square means x square into 1, 0.2, 2 square into 0.3, 3 square into 0.5. Okay. And the last probability 0.3, 2.3 we square it and subtract it, we get 0.61. Got it? Simple questions, simple answers. Probability is easier if you just remember the basics of 8, 9, 10, 11, 12, whatever it is. So let me just pin my camera. I forgot to pin it. Given two random variables x and y with joint probability distribution, what is the covariance between x and y? Can anyone answer it? How do you compute covariance? Somebody please speak. Am I audible? How do you compute covariance? How do you compute covariance? Anyone? It's very simple. We compute marginal probabilities for x and y, then we compute x and we compute this whole thing, and then we multiply like this, like what we did, na? E of x square minus times e of x whole square. Okay. So e of x is equal to 1 is summing all the probabilities for x is equal to 1. 1, 1, 1, that is 0.25, 0.25, 0.0. Okay. So that gives you 0.5. Just a second. For similarly for y is equal to 1, y is equal to 2, x is equal to 2. So to compute x, again what we do is we multiply this whole thing as it is. To compute x, y, we multiply this thing, what we call this joint interaction between x and y. 1 comma 1, this probability, 1 comma 2 probability, 1 comma 3 probability, 2 comma 1, 2 comma 2, 2 comma 3 probability. We ultimately get this value, and then we just compute it. Very simple. Just put it in the formula, you get the answer. Okay, any other question? What covariance basically computes the what we call the given some probability distributions. If they are asked to behave, if they are asked, what we say, what do we call it? To interact in the same space. Okay, how much spread will they have, like that, the distribution. Got it? Something similar like that. If there is one distribution, you compute variance of that distribution. That tells you what is the spread of that distribution. So if the two distributions are asked to behave in the same space, so that basically gives you the covariance. Means covariance can compute the spread of the joint interaction between them. So last two questions are there. A company is analyzing relationship between number of advertisements X and number of products Y sold for two different products over 4 weeks. Joint distribution is given below. You have to compute covariance. Again, same thing. And this one is nice. So an email system correctly identifies 98% of spam emails as true positives, while correctly identifies 97% as true negatives. 20% are spam. What is the probability that spam actually identified will be spam? Let's see the solution directly. So you have to find, you have been given these three probabilities. Okay. Probability of finding spam is there, probability of finding positive spam, so you invert it. Okay, spam positive, you invert it, you get this thing. The correct answer is this thing. So how do we invert it? Positive spam positive is positive spam into spam divided by spam positive. Okay, the positive becomes this sum of all things: positive spam, spam, positive, no spam, no spam. Okay, so you get this answer. Very simple Bayes theorem formulas. Any doubts? For your assignments, the solutions might be provided in a week or two. I hope so they will be provided. But if they are not provided, you can just raise a query on discussion forum and ask professor to provide solutions for current sessions, week 1 and 2 assignments. Okay. Mm-hmm. I generally don't prefer that. Like I can solve it for you for like upcoming week. Okay, but what is the deadline for upcoming week? That should be 12, I think. Okay. Okay, so I have half an hour. I can discuss week three. Let's discuss it. Okay, as you're saying, let's discuss it. I won't take more than 15 minutes. See, week three quiz, week three solutions are provided here. I won't take more than 15 minutes. I'll just discuss it roughly because yeah, I know. Just today only the was released. Sorry. Yeah, yeah. Today only afternoon. Yeah, yeah. I'm also there. I'm also in that course. I have enrolled it. I don't study. Just I have enrolled it. So I also get emails. Okay, so this is week three. What are the topics for week three? I think it's linear regression type of thing. Okay, I'm tired of reading. Can someone read it out loud for me? Okay. So let me just see a few things here. If an algorithm is observed not to consistently reduce, it means it's not reducing consistently, it's increasing. It's reducing, then increasing, reducing, then increasing. It means it's oscillating. When the algorithm is oscillating, the gradient descent is oscillating, the loss, which means the learning rate is quite high, which means from in this curve, the algorithm is shifting from this side of the curve to that side. It's jumping from here and here. Okay. So you have to reduce the learning rate so that it hops on that same curve properly. It should not jump to this side. Okay. So you have to decrease the learning rate slightly. The algorithm is likely oscillating without diverging or converging. This one is correct option. Yeah, this one is correct option. Consider the following function. Critical point, you have to find it. How do you determine critical point? You can compute, what do you say? Uh, Derivatives. So just compute the derivative of this with respect to x and y and find the answer. Can someone compute it for me, or let me see the, okay, let's see the solution directly. Derivative of partial derivative, yeah, forgot the term, partial derivative. Compute the derivative with respect to x, you get this thing. Compute derivative with respect to y, you get this thing. So x is equal to 2, y is equal to minus 2. That will be the answer. Yeah. And at this point, this is the critical point of inflection, whatever you call it. At this point, the derivative is 0. Not point of inflection actually, critical point only. Yeah, it can also be called point of inflection. For the above function, evaluate whether the identified points, critical point represent a local minimum, local maximum, saddle point, none of the above. Okay. So how do you find local? You basically compute second derivative. That is how you find it. This is Hessian matrix to compute it. So second derivative of will be 4 of x with respect to x, with respect to y it will be 6, with respect to dy dx it will be 0. So determinant of so Hessian matrix becomes this 4 0 0 6. The determinant becomes 24. So when derivative of determinant of Hessian matrix is greater than 0 and this point is greater than 0, it's a local minimum. Okay, if this point is less than 0, it becomes say what we call local maximum. Okay, so there are like 4 or 5 conditions for determinant test. You might have seen it. Learning rate is 0.1. You're starting with 0, 0. You have to find after 3 iterations. So that's very simple. I don't know, like I think that you just have to directly put the formula and you will get the answer. Okay, so you have to just compute derivative. You have to just compute, write the code, simply run it on 3 iterations. You will get these values. Very simple. Okay, so for the same function above, assume the gradient starts from 0.0 with learning rate 0.01. The learning rate is reduced by 0.01. Find the values of x and y after 3 iterations of gradient descent. Which learning rate brings the point closer to theoretical minimum of the function? Okay, they have asked to find the values. The values are not given. So you have to find, let's just see the answer. Okay, directly see the answer. 0.1, obviously it moves faster towards the minimum, but for 0.01 the values will be minus 0.05 and 0.11. The values have been computed, but the answer is simple as that. So obviously if we just have to see if 0.01 does not give us the point of inflection. It does not oscillate the loss, otherwise it will move faster towards minimum. Okay, consider a data set with 2 features and dependent variable y. The data set is given as follows. The cost is given like this. Okay, you have to basically perform gradient descent of 1 iteration and compute this thing. Very simple question again. So, hello. Somebody is saying something. It is fast. See, it's just a learning rate. It's saying if you increase the learning rate, what will happen? Obviously, the point it will move towards the faster towards the minimum, because the learning rate increases the slope. Basically, if you multiply with a higher learning rate, the slope gets increased. Okay, that the magnitude of slope, not slope, the magnitude of slope. In this direction, the slope is negative. Okay, so magnitude increases, so gradient descent becomes faster. So all questions related to gradient descent only, you can just compute one epoch. I'll just show you the solution. So in this as well, they are computed. They have taken derivatives with respect to theta 0, theta 1 and theta 2. After calculating and apply, you get this thing. Simple as that. Just apply this rule and you get the answer. Absolute difference in cost function before and after first iteration. So just compute it. Initially it was that, after it was that, absolute difference is around 74.2. That's what you are getting it. Which of the following is true about gradient descent? In gradient descent, I will just read it out. The goal is to minimize a function by iteratively moving in the direction of steepest descent. Since the positive gradient points in the direction of greatest rate increase, since the positive gradient points in the direction of the greatest rate of increase of the function, moving in the opposite direction will lead to decreasing the function value, which is what we want to minimize the process. Hence, after each iteration, we modify the parameter vector in the direction opposite to the gradient. Yeah, basically subtract the gradient, right? So we modify the parameters in the opposite direction of the gradient. So that's why we move in the direction of negative gradient. So if the gradient is say 0.4, we means which means that we are in the positive side of the gradient. We subtract it from the values of weight. So we move in the opposite direction of the weight. Once the gradient is 0.5, okay, so we move in this direction. Okay, so second last question. Given two vectors a and b, what is the correct partial derivative of a with respect to b? Which one? Which is a? So a1 respect to v1, a1 respect to b2, a2 with respect to b1, a2 with respect to b2. This will be the answer. a1 with a2, a1 with b2, a2 with b1, a2 with b2. Yeah, a1 b1, a1 b2. Sorry, a2 b1, a2 b2. This one. Last question. Given the function, determine the theoretical value of second component of argmin. Again, you have to compute loss. Take the which when it reaches minimum. This means you have to compute the first order partial derivative. Yeah, I'm explaining week 3 only. What was? Did anyone say something? Hello? I heard that ding sound. So you compute partial derivative of this thing, first order partial derivative, and then equal to 0. This gives you 4w2 is equal to. Achha, with respect to weight 2. It's given with respect to weight. Second component is w2. Okay. With respect to weight 2, you get this value. And so w2 becomes minus 0.25. The correct answer is minus 0.25. Sorry, minus 2.5. So yeah, that's all about week 3 last year's problems. Any doubts till now? I don't think so. There will be doubts because the questions are very simple, formula based. So yeah, I think that will be all for today. Or maybe I should say tonight. Night is this evening. Okay, so any other questions? Hello? Somebody has unmuted themselves. Okay. So I think that will be all for today, tonight. Have a good night, good evening, and enjoy the weekend. Let's meet next week. Till then, you're welcome. Thanks a lot, guys. Let's meet next week. Listen to me first. I'm not finished yet. Next week we'll discuss week 3 solutions of this week. This year, and week 4 solutions of last year. Okay, and also we'll start with something. Okay. So I wanted to start something, but we had some pending tasks, so we finished it this week. And next week, let's meet it. Yeah, we will have quite an interesting session next week when we will be discussing a lot of stuff which will be converted to your machine learning coding. Okay, in Python. So yeah, that's all for today. Thanks a lot, guys. Bye bye. I cannot send it. I am just added to it. I am not allowed. I don't know I'm allowed to send it or not. Okay, as a TA, I've been given access. That's why I discussed in video. You can just go to the video and watch it and just copy paste it, whatever you feel like. I don't know. I will ask NPTEL team if I'm allowed to share or not. I'll ask. NPTEL team has shared, and if my screen is visible, I will show you. if you go to the course, you go to, let me minimize it, I've zoomed a lot. See, this is a session reminder, this is a survey. Okay, they have not shared it. They shared for some of, they have shared it. I got an email. Yeah, this one. Yeah, this one. Yeah, so I upload videos here. I will upload the video here. I will put the link here. Uh, I don't have anything to share on Drive, so I'll put the video link here by tomorrow, and you will be getting an email. Okay. Okay, chalo. Thanks a lot. Bye bye, guys. Take care. Bye.